Most blockchains work as a decentralized digital ledger, which is maintained by a distributed network of computers. Such a technology allowed the creation of trustless economic systems, where borderless financial transactions could be executed without the need for intermediaries. Since traditional banking and payment systems are heavily dependent on trust, cryptocurrencies are now being adopted as a viable alternative because they rely on blockchain technology and are used within trustless systems. The participants of a cryptocurrency network need to regularly agree on the current state of the blockchain, and that is what we call consensus achievement. However, reaching consensus on distributed systems in a safe and efficient way is far from being an easy task. So, how can a distributed network of computer nodes agree on a decision if some of the nodes are likely to fail or act dishonestly? This is the fundamental question of the Byzantine Generals problem, which gave birth to the concept of Byzantine fault tolerance, sometimes referred to as BFT. The Byzantine Generals problem was conceived in 1982 as a logical dilemma that illustrates how a group of generals may have communication problems when trying to agree on their next move. Imagine that each general has its own army, and each group is situated in different locations around the target city. The generals need to agree on either attacking or retreating. It doesn't matter whether they attack or retreat, as long as they all agree on a common decision. So, we may consider the following requirements. Each general has to decide and vote on either attacking or retreating. After the vote is made, it cannot be changed. All generals have to agree on the same decision and execute it in coordination. However, they are only able to communicate through messages, and the central challenge of the Byzantine Generals problem is that the messages can get somehow delayed, destroyed, or lost. Even if a message is successfully delivered, one or more generals may choose, for whatever reason, to send a fraudulent message to confuse others, leading to a total failure. If we apply the dilemma to blockchains, each general represents a network node and they need to reach consensus on the current state of the system. This means that the majority of participants within a distributed network have to agree and execute the same action in order to avoid failures. What is Byzantine fault tolerance? Byzantine fault tolerance is the property of a system that is able to resist the class of failures derived from the Byzantine Generals problem. In other words, a Byzantine fault-tolerant system is able to continue operating even if some of the nodes fail to communicate or act maliciously. There are multiple ways of building a Byzantine fault-tolerant blockchain, which are related to the different types of consensus algorithms. We can define a consensus algorithm as the mechanism through which a blockchain network reaches consensus. The algorithm used by Bitcoin is called proof of work and is one of the most common implementations. While the Bitcoin protocol defines the rules, the consensus algorithm determines how these rules will be followed, for instance, during the validation of transactions. The concept of proof of work is older than cryptocurrencies, but Satoshi Nakamoto developed a modified version that enabled the creation of Bitcoin as a Byzantine fault-tolerant system. Although proof of work is not 100% tolerant to faults, it has proven to be one of the most secure implementations for blockchain networks and is considered by many as one of the most genius solutions to the Byzantine faults. Securing these systems is an ongoing effort, and the existing consensus algorithms are yet to overcome a few limitations, but the potential applications are certainly inspiring widespread innovation. Beyond the blockchain industry, a few use cases of Byzantine fault-tolerant systems include the aviation, space, and nuclear power industries.